terms of machine learning operations. We'll be introducing the concepts, and we will have a detailed demo using one of the tool which is available in the market. So agenda for today's session is we will understand from a machine learning perspective what is the current workflow that is being followed across the world, what are all the problems faced by the developers, MLOps as such, how it can actually provide solutions, and what are all the frameworks which are available in the market which are helping us to actually solve the problems that the developers or the data scientists and the machine learning engineers face in terms of your AI development, machine learning developments, and so on and so forth. And among this list of frameworks, we will take one framework. We will walk through live in terms of starting from deploying that framework, installing that framework, and we will take multiple scenarios. We will start from the data perspective, and we will build a model and see using that framework how we can actually track how the ML, machine learning ops is helping. ML ops as such consist of various different features. So we are going to focus on from a data scientist or machine learning engineering perspective, and there is another feature in terms of your live monitoring and so on and so forth. We have covered it in the previous sessions in terms of using Grafana and Prometheus and so on and so forth. We have covered it back. So our focus is predominantly on ML ops on today's session. So if you look at a typical machine learning workflow, it starts from your problem definition in terms of what problem that you are solving, and that based on the problem you start acquiring the data. And once you acquire the data, you cannot directly put the data into operations, and you may require to prepare your data. We call it as an EDA process, exploratory data analysis, as part of your um, cleaning the data and having the data, make it ready for your actual experimentation. Once you have the data cleaned, you take that data to your model development, and once the development, you find algorithms that would be suitable for it, and you apply that particular algorithm and you train that particular data. Here, as part of the training, you will evaluate how good your model is. There are various different parameters through which you will evaluate based on what is the business goal that you are trying to achieve. It could be an accuracy that you wanted to evaluate, or it could be various other details that you wanted to evaluate. You typically iterate on this particular area where you will, if the accuracy is not enough, you go back and prepare your data again, modify your data, and probably at the data side you will do the modification, getting more data or fine tuning your data to have more accuracy, or at the model development end you may use a different set of algorithms for evaluating and so on and so forth. And once you come to a final conclusion that this is my baseline model, that I believe it is good enough to actually take into live, you go ahead and deploy this particular model to production. And once you put that model to production, you use that model for your predictions and so on and so forth. And effectively, if you look at in the live scenario, this is not where your actual problem solves. Your problem will probably start occurring after you take your data or the model to the production. There could be a lot of items that could go wrong when your model is in the production as such. So effectively, instead of looking at your machine learning workflow as a linear execution, I wish to mentioned this, the life cycle of your machine learning operation, it's a circular one. You probably know, start gathering the data as a first step, and you go for data preparation and your EDA process, and you analyze the data, you train your model, you test your model, and once you are done with that, the final model, you take it to deployment. But that it does not stop there. Effectively, you need to again start monitoring this particular deployment and see what kind of a problem your prediction has, or any model drift or data drift that is happening in the actual deployed model. And if anything that you identify as part of your monitoring exercise, you again go to the gathering data specific to the problem, and again the loop continues. This is a typical machine learning life cycle that you can see on pretty much on all major projects that you can think of. All the live execution will have the same implementation in place. So I wanted to understand from the audience in terms of what kind of a problem that you face in terms of you got the data, you defined your machine learning problem statement. This is what you are trying to solve. But before you start creating, reviewing your training and so on and so forth, what kind of a problem you guys faced? I wish to have this as an interactive session. Probably you can share part of your EDA process, what kind of a problem you face, part of your training, what kind of a problem you face. I wish to understand from the team. Does anybody has faced any problem in terms of your machine learning development flow? Anybody would like to volunteer?
Hi, Prasanna. Good evening. This is Manigandan.
Yes, madam.
Yeah, I just want to share our experience on developing a NLP model actually.
Okay.
So we had lakhs and lakhs of rows from CSV file, and we were we were in some ticket automation actually. So based on the comments and the reviews given by the user, we
Mhm.
used to process a lot of text data. So in that
Okay.
data preparation, actually it has the human typed text will be there, and also some logs will be there, lot of logs, including the timestamp, the username, everything.
Very good.
So it
Okay.
was a big challenge for us to identify what are the human entered texts and what are the logs coming from the server. We have to clean up them. We It's a kind of uh, sentiment analysis, so that how out of 5 points, how much point the user will be giving for one particular incident arised. So handling such a lot of machine data and timestamps, all those things, it was a big challenge for us during that time actually.
Completely agree, Mani. Very good point.
Okay.
We will see how MLOps can actually help you in terms of efficiently handle such as use cases. I will specifically touch upon this use case and see part of the demo. I'll show you how, when you are doing EDA, probably when you are cleaning the data, what kind of
Yes.
activities that you can do, so that you can keep
Mhm.
on going back or going front on the data that you are looking at. So you can keep track of what kind of a changes that you are making in the whole process, how you can actually track the whole changes that you are doing. We will see how you can actually solve that problem on today's session.
Sure,
Wonderful.
sure, sure, Prasanna. Thanks.
Any other problems in terms of part of your training your model? Any other problems from a data perspective? I got your problem. Any other problems in terms of training? Right. So nothing to worry. We will cover in terms of what kind of a problem that the developer face. Effectively, if you look at uh, your machine learning project development, it does not just require you to have one set of skill. It is a multitude of skill that is required, and your understanding on the math and statistics will help you on identifying what is the best model or best algorithm that you can take for your implementation. And understanding on the data processing capability will help you in terms of how well that you can actually clean the data and process your data and so on and so forth. And these two skills alone might not help in the case of data engineering. How you are going to, like Mani was talking about, a large data set that he has got, having that processed on your local machine is virtually impossible. And if you load it on your Jupyter or any other platform for processing, at some point in time your model development might fail, because it will not have the capacity to actually handle such a large data. So you need to have a data engineering skill, including some infrastructure knowledge, so that you understand how you can actually take your data to a proper environment setup for your whole model development ecosystem, and utilize that for your whole development asset. So the skill set that would be required is not just your math or statistics, not just your basic SQL or your EDA skills, but you may need some part of how do you actually have the infrastructure knowledge that will help you have a holistic view on your end-to-end machine learning development life cycle. And where MLOps comes is in terms of your data engineering and your DevOps perspective. DevOps as such were there for many, many years and decades. It was purely focused on your typical SDLC automation, your typical software development lifecycle automation. But in the case of MLOps, we're few purely focused on machine learning lifecycle, how you can actually automate the machine learning lifecycle as such. Because a typical SDLC development or the DevOps would require a completely different approach of managing your execution. But in the case of MLOps, it requires a completely different type of approach to handle things. Now, let's look at some of the problems faced by the developers. So there are two scenarios. One scenario is in terms of developing the model. While a developer is developing a model, what kind of a problems he face? And once the other scenario is once the developer developed the model, after he put that model to production, what kind of a problem he face? And two important problem that you can think of um, in terms of both combination of your development life cycle as well as in the live production life cycle is first is a model drift, and the second is a data drift. The model drift could come through where there is a change in the complete business requirement itself. So, because there is a change in the business requirement, the kind of data that is being fed into the model is completely changed. The way in which it is going to give a response is going to completely change. In that case, you may have to take out your model and build a new type of model, new version of your model, and have it deployed to your production. In the case of data drift, it could be because of various reasons. It could be because of a seasonality, or it could be because of a consumer behavior, or it could be completely new, like new product has come. And th- these are some of the examples of what could lead to a data drift as such. So apart from these problems, if you look at from a pure implementation or the development perspective, as an ML engineer or a data scientist, and they wish to have an iterative approach of solving any machine learning problem. Once a problem statement is given, you probably take the data and do a basic processing of the data, and do a baselining of your machine learning algorithm. And probably you get a baselining version of your machine learning algorithm. Say accuracy is the measure that you are measuring. Say you are getting 75% as your current accuracy, but then you can negotiate with the business and see my the data that you have given, and with the initial set of models that I have done, I am baselining the accuracy that we have received as 75%. But in this case, business would like to take the 75% to 90%. So now how do I take my 75% accuracy to 90%? It will not happen overnight. It may require you to iterate on multiple rounds with the data and the algorithm that you have, and iterate on how you can actually improve upon the whole performance of the machine learning model. So, typical requirement for a data scientist or a machine learning engineer is I should have an effective way of tracking and processing in an iterative way of development. If you take a typical, website development or your mobile application development or so on and so forth, it does not go through this process. If a requirement is defined, typically that requirement is frozen at the beginning of the development itself, before the development starts. And for a mobile app or your web app, the developer predominantly focuses on what is required from the customer. They could be using your prototypes or wireframes or so on and so forth as a implementation process, and they simply replicate what is required in terms of your screens and application that is required. It does not go through such a rigorous iterative process that is required in terms of a machine learning process. So when you want to think about tools that is going to help you for your machine learning development, you need to think of how the tools are going to help you to implement a effective iterative development process. So that is very, very important. The next is in terms of tracking the metrics. You could be part of your development tracking multiple matrices as part of your project. And these the one of the basic problem that machine learning engineers face is hyperparameter tuning. So you have, for a specific algorithm, let's say 10 different hyperparameters, and you could be taking multiple values for these hyperparameters and see which is the best one that I am going to use for my development. But if your data, as Mani said, is very huge, and just to have one hyperparameter to put in and to verify the details, it may take a couple of hours to complete one iteration. So if you are applying multiple hyperparameters to find the best one, it may take a couple of days for you to actually identify the best hyperparameter that is suitable for you. But in this case, by the time you complete all the different hyperparameters, you might have done multiple iterations of your machine learning application. So we may have to keep track of, okay, day before yesterday I have used a hyperparameter and I got an accuracy of say 85%, and now I'm using a different hyperparameter and it is giving me only 79%. I could, go back to that particular one, but I forgot what is the actual parameters I have given. This is a very common problem, and you need to keep track of different experiments that you are doing. And on an iterative basis, you should have a logging mechanism in place so that all the iterations that you are doing is properly logged, and you should be able to go back and search which is the best hyperparameter among the 100 different experiments that I have done is good for me. So that is currently not available in the typical development. You need tools like MLOps and the frameworks can help you actually build that whole process. And you also need, in terms of managing your actual machine learning source code, and you should have an ability to collaborate with your friends or peer data scientists to understand how they have done something and quickly look at their process and implement a similar concept on your model development as such. So also you may need some checkpoints in terms of assuming you are performing a large data cleaning exercise, and you need to checkpoint the data at a certain stage, so that in case if something goes wrong, you have some checkpoints are available. You can always go back to that particular checkpoint for your implementation as such. And you should have an ability to actually automate the end-to-end process and have approach to proper validation and stage development as part of your machine learning development process. I might be giving you all the theoretical part. Do not worry if you don't understand any of this, because we're going to look at from ground zero how we're going to take the data, how we're going to process, how we're going to actually monitor our development process in the demo. So that way you will understand how we are going to do all these problems, how we are going to solve all these problems using our MLOps. We're going to see it today. Okay. And now MLOps as such comes in as a combination of your DevOps, your machine learning, and data engineering together. It's an intersection of all these three is where the MLOps resides, and that will help you on achieving whatever the problem that we have discussed to solve that problem. Now, what is a goal? So effectively, we should be able to create models, machine learning models with reusable ML pipelines, and we should have an ability to automate mundane tasks, and we should have an ability to monitor the performance, monitor the data drift, and you should have an automatic data trial, audit trial for your whole machine learning process. That's the goal of your MLOps. So you could consider that the MLOps actually solves multiple stages of your actual machine learning process. There could be MLOps that can be focused on your development lifecycle of your machine learning algorithm. There could be MLOps that can actually focus on your production lifecycle of your your model from a monitoring perspective and redevelopment, reversioning, and retraining and perspective as such. So there are multiple, you can say, hats the MLOp wears in terms of what kind of a problem that it is trying to solve. We will see certain set of problems on today's session on how MLOps can actually help you solve that one. Let's look at some of the frameworks which are available. And if you look at, there are very few in terms of can cover end to end of all the problems that we are talking about. From the time you take the data till you take it to a production and monitoring perspective. These are some of the frameworks. This is not a finite list of frameworks, but there are so many others which I have left out. You can name. There are a lot of frameworks are available. Prominent ones that I have listed down here, and a couple of these frameworks are typically open source, and couple of them are basically a proprietary one. You have Azure Machine Learning supports the MLOps, SageMaker from Amazon, Neptune AI, Domino, Comet. All these are proprietary frameworks. You have like MLflow, Kubeflow. Uh, these are predominantly open source framework, which are going to help you in terms of implementing your MLOps solution. So as I said, there are different focus for MLOps in terms of sometimes your focus is on the development life cycle, sometimes your focus is on the production life cycle. You could go for a specialized tool focused on individual one. In the whole process, if you look at ML flow that we are seeing here, has a beautiful set of tools and technology in terms of development lifecycle automation as such, development lifecycle monitoring, and helping the data scientists and the data engineers to better perform their operations as part of their development. So that's where ML flow as such is having a greater impact from a monitoring perspective, and identifying what kind of a problem happens in the case of live monitoring. There are proprietary tools which combines all of them together, but there are separate set of monitoring solutions, for example Grafana and Prometheus and so on and so forth. We're helping you to monitor the live production environment, machine learning models in the live. So here on today's session, what we're going to look at is we're going to look at from an ML flow point of view, from starting to the end, how a developer lifecycle is effectively handled with the sample examples as such. So now let me introduce ML flow. ML flow is a wonderful open source tool which can actually help you track your model runs, all your model parameters, matrices, your results, your data used, and your code. Everything can be tracked by using ML flow. And it has a beautiful set of features in terms of how you can actually package your solution, how you can actually take it to multiple different sources for serving your machine learning model. We will see in deep about what are all the different features of ML flow as such. High level, you look at ML flow tracking, ML flow projects, ML flow models, and ML flow registry are the four important pieces from the ML flow as such. The tracking part plays a very important role from a developer point of view, where it helps you do end to end of tracking whatever that you do part of your machine learning lifecycle. And ML flow projects help you actually format and reproduce your runs on any platform. In the sense, you develop, typically the machine learning engineers or the data science scientists develop their applications or the models on their local, and part of their production life cycle they wanted to take take that item to production with, could be a multitude of services available. TensorFlow serving, you have SageMaker, you have Azure machine learning, you have so many other services are available in terms of serving, taking your model to production. Depend on your customer need, you will basically provide that particular feature for taking it forward. And in the case of ML flow models, how you can actually have your models that you have created can be taken up for your serving perspective as such. And within ML flow itself provides an option of serving your model using ML flow models. And a model registry helps you store all the different models that you have created, and that can be stored and managed beautifully, part of your model registry. All these are combined and provided as an open source solution for you to manage. And the beauty of ML flow is you name a type of algorithm or type of company that you are working with for your machine learning operation. Pretty much all of them were part of their workflow. And effectively, TensorFlow, PyTorch, Keras, Spark, Scikit-learn were the normal set of tools that predominantly everyone uses for their typical machine learning development. If you go for specific, let's say NLP based use cases, you could be using Hugging Faces, or an enterprise based solutions, you could be using H2O.ai. So all these solutions have an integration with MLflow, so you can very easily use MLflow as part of your actual uh, implementation. So who are all contributing? As I said, it is an open source solution, and there are so many people are contributing as part of their development. It is promoted by a company called Databricks. I'm sure most of you who would have heard about Spark. Databricks were the actual creators of the Spark ecosystem, and they have Databricks Spark, Spark ML, and so on and so forth available as part of their ecosystem. And so they were the promoters of it, but predominantly supported by a large group of well-known brands. They are actually supporting as part of the implementation. So let's start with the demo of it, and the source code of the whole exercise have been already shared in the GitHub. I've already shared the GitHub link for all of you to enjoy in the in the presentation link that I've shared. If you want, I can just share it in the chat. What is the link where you can actually access the details um, to all of you. So this is the link where you can enjoy. So coming back to our installation. So this is how you will install the MLflow. There is a command, simple command called pip install MLflow. It will help you install the MLflow on your machine. And part of the demo, these are some of the prerequisites that is required. We need Jupyter notebooks for managing our IPython files, pandas. I'm sure most of you know, for taking your data as a data frames and manipulating the data, we use panda, and all the algorithms that are created will be used by using scikit-learn, and we'll be using matplotlib, that is mainly used for representing graphs and images as part of your machine learning model execution. NumPy is also for your data manipulation. So these are the base frameworks that is required as part of our implementation as such. So I'm using Mac. I'm sure if you are using any particular uh, platform, you should be able to install the MLflow just by using the command pip install MLflow. Just for reference, I will just show the command I have already installed and it is running, and MLflow. That's it. You will be able to get the MLflow installed as part of your environment. So the MLflow as such can be deployed into multiple scenarios, can be used in multiple scenarios. Let's look at the scenarios. So the first scenario is you can use MLflow as part of your local machine, where all the artifacts that you are getting and your data, like parameters that you are taking, all are saved within your local machine. So on today's demo, I have taken this approach for demonstration, where both my artifacts and the details that I am tracking, everything will be stored in the file store local machine. This will be the demo that I will be showing, but it is not the only approach. You have multiple other approach. The second approach is in terms of, you can, the artifacts, you can store it in a local file server, and there is the file store, for example, all your parameters, your execution details, you can store it in a database. You can store it in a database, probably an SQLite database. They recently also support multiple other database varieties as well as part of MLflow as such. And the third scenario is you can use a tracking server. What is this tracking as such? Is so typical development of your machine learning algorithm or your machine learning data processing and so on and so forth. Typically, majority of us will be using Jupyter Notebook for our development. So you can, whatever activity that you are doing, you have to get tracked by somebody. So this tracking can happen on your local machine, or you can have an external tracking server set up, and this tracking server can keep on tracking your whatever the operation that you are doing on your local machine. There could be lot of reasons why you need a tracking server. In terms, it could be some security requirement from your organization, or it could be like you don't want to bother your local machine with so much of your machine learning runs. You rather use the tracking server as a separate entity for storing how you are performing on the machine learning development as such. So the actual system will utilize the the code and all will be available on your local, but the tracking server will be a separate entity, and using which you will be able to interact with. Do not worry if you do not understand this. When we see the demo of it, you will clearly understand it. And the fourth option is your tracking server can have a dedicated database for saving the details. So as I told you previously that SQLite is not the one. You can also use, say, a tracking server can be configured using, say, Postgres SQL, and that can be used for tracking your parameters, matrices, and different stages of your data logs and so on and so forth. All can be tracked as a separate entity altogether. In the local machine, you might be just using MLflow for your actual operations as such. So these are multiple varieties by which you can actually implement MLflow. So so as I said, the tracking is a very important thing. So typically, as I said, you could be developing your whole code on a notebook, and you could be developing and saving it on your source control. Could be GitHub or your local in your company's Git based storage and so on and so forth. And the tracking helps to monitor each and everything that you're doing on your notebook or on your GitHub. And using a tracking API, you can actually integrate and save it on a separate server or so on and so forth. You can see them using something called a tracking UI. What's happening? The whole thing can be seen by using something called a tracking UI. We will show that how the tracking UI looks shortly. So part of the tracking and all the features that the tracking UI that brings in, these are some of the important concept that it brings in. The first is run. So the run, we all are doing runs on our Jupyter notebook or any machine learning tools that you are using for your development. You do a run, and it basically tracks execution of your code and track the details on your local or a remote tracking server. Okay, and what other informations concept that takes, it tracks code version and your source code, multiple source code that you are doing. You can actually monitor them. Could be that, as Mani said, today he could be working on NLP problem. Suddenly his boss comes and say, hey, there is a regression problem I want you to solve tomorrow, and he may have to switch to the regression problem. And after 2 3 days, once he completes, he may have to come back to the NLP problem he was working on. He should not be losing all that he has done on the previous instances. So there should be a way he can actually track what is the level that he has done. From there he can actually take it forward. It is not just his code, but also what are all the different parameters that he has used, what are all the different matrices that he has been working or fine tuning, what are all the different artifacts that he is doing. Artifacts, it could be a data file, or it could be anything related to your whole machine learning development. It could be an image that you are actually trying to process, it could be an audio file that you are trying to process. All these are artifacts as part of your development as such. All these are tracked, and you should have an option of searching for them in a very effective way. Searching in terms of anything goes wrong, I should be able to go back and identify the details effectively. So search for them effectively. So these are some of the concept. We will see them each and every one of them as part of the demo. Okay. So typical your machine learning life cycle, from the raw data, you could be using multiple different tools and technology for managing your raw data. And as part of your data preparation, you could be using multiple different tools and technology for preparation. Similarly, for training, you could be using multiple different things, but all of them can be tracked by using ML flow tracking. And once the raw data preparation and training is done, you go for deployment. In the deployment also, you could be using multiple different approaches, but then the ML flow models help you actually deploy it very effectively. We'll see them also how it is done. Okay, so these are two different features of ML flow. Effectively, there are four different are available, but in this diagram talks about two different features of it. Okay, and the ML flow tracking, as I said, it does all that we just talked about. The ML flow models were to help you serve the model effectively across diverse deployment platforms. And the ML flow projects are for packaging the models for reproducibility or reusability in any platform. So you could be, your friend could be working on some algorithm, he put it um, into GitHub as an ML flow project, and directly on GitHub you can actually execute and see how that particular project actually works. You don't need to even set up anything on your local, if you have the ML flow project in place. That's the beauty of ML flow projects as such. So these are multiple approaches, and these are some of the sample commands that are used as part of the solution. So let me just go back to the actual demo part of it. We said how to actually install your ML flow. So I have completed my installation. Once the installation is done, the next step is on getting our ML flow tracking UI. The ML flow tracking UI, the command to actually get the ML flow tracking UI is this. Let me just go to the, I have multiple command line. Let me just go to the corresponding one which has that feature. One second. Okay. Right. So just for our clarity, I'm just maximizing it. So if you look at here, there is a folder I created called MLOps. The first thing what I am doing is, this is the two line that you can see here. I have highlighted here. I hope you are able to see them. And here what I am doing is, the first step is the place where I am having my project. The folder that I'm using is called MLOps. I'm getting into that particular folder. And once I have the ML flow installed, then I can run like ML flow UI. As soon as I run this ML flow UI, it will provide me this detail that it is starting the MLflow UI, and I will be able to access the MLflow UI using this particular link. So if I take this and if I uh, go to the same item, same place, and this is the link that you saw. So with the 5000 as the actual port number, when I click on it, so this is the MLflow UI that you receive as such. So we have completed the installation and we have started our MLflow UI. So that's the two activities done. So the next activity is in terms of our Jupyter lab. I have some projects I need to open and see all the projects which are there, and I wanted to work on it. So if you have a Jupyter notebook, Jupyter installed, you can just type Jupyter notebooks, and that will basically open my Jupyter like this. Now I have multiple different IPython library, all these IPython files, and all these files are already shared in the GitHub for your reference. Now let's understand the different folders here. So the first folder is data. This is, I have created this folder. So there are two data that we are going to utilize, that we will come back to that. And I have this data processed, image, ML runs, and output. All these four folders that you are seeing, all were created by the ML flow. I have not created them. These four folders were created by ML flow to manage my actual execution of the details. And these are the different experiments that we are going to see on today's session. Okay, so I'm going to start as usual with hello world. So assuming that this is a simple hello world application. So as part of this, we have completed our ML flow installation. Let me just increase the actual width of it so that you can enjoy the view. We have already completed using our command line, so I'm not running this. So the next important thing is I have to import the ML flow as a Python library. The OS is mainly used for your interaction with the OS operating system, and the random is basically for generating random items. Matplot library is for your plotting, and pyplot that you are taking as PLT. Pandas, we all know it is for your data processing. sklearn is the actual sklearn for your machine learning creation. So if I run it, it is saying that MLflow version is 1.28 and all other library versions are provided here. So the first operation is help. It will give you all the help specific commands. What are all the different commands which are there? All these commands are actually provided here as part of help. How do you actually interact with multiple different frameworks, and all those details are provided here. So let's go to our hello world usage of our ML flow. So I'm defining a simple method. Effectively, before you start any experiment, you have to name that experiment in the ML flow. So I'm defining my ML flow experiment. I'm going to call it as hello world. You can call anything that you want. So in the for our experiment as such, we can actually even look at a different one, because this is the MLflow UI. I have already executed them. Then you can see that these are all already available. For our understanding perspective, what we can do is we can call it as, say, um, call it as our MLOps live demo. So this is my experiment. And before you start doing with anything with ML flow, you have to do something called mlflow.startrun. That is the first command that you do before you do anything. And the next thing is there are two different commands or uh, options methods available in MLflow. One is set tag, another one is log parameters. And the set tag is used to set a specific key value pair, and this information will be logged. This is all part of your MLflow tracking activity. You have any parameters that you are tracking. Let's say we are going to call it as param1, and this param1 is just a random value that we are taking, and that value will get logged as part of your log param. And there is something called log metrics. The metrics used for saving a specific metrics. Here there is a hello world, so you're not seeing a proper value here. I will show in the next follow-up demo for a specific problem that we're going to take from a machine learning perspective. We're going to solve it. There we will do a real metrics and logging the details. Okay. And you can set tags as similar to this log parameters and log matrices. And you have something called log artifact. We will see in detail what is this log artifact. So before you start the MLflow, you do this start run. At the end of the whole flow, you will do something called MLflow end run. So I will just execute this. This is just defining a run, a method called run that we are going to define, and this is going to take a name as a parameter. If there is no name, then a blank will be taken up. Let me just call this method without passing anything. Even if I do, when I ran, I get the response that experiment with the name MLOps live demo does not exist, creating that experiment. And it is saying a model run, there is an ID got created for you. Now the same run as a method that I'm calling again with a specific parameter in place. I'm running here. So once I ran, it gives me that it's with a different model run detail. Okay. Now if I go back to my MLflow and refresh my screen, now you can see that there is a MLOps live demo. This is what we have just created. And in this MLOps live demo, we had done two runs. The first run did not had any run name. We just gave a blank, so we got a blank output. The second run basically came with a local run here as a name that is mentioned here. The other details is in terms of tags, parameters, and matrices that you can see it here. For example, we have two matrices. We called them as foo and foo1. If I go back to my hello world, if I look at here, this is the matrix foo and foo1, and my param is called param1, and all these values are logged here. These are random value that we are taking and displaying the details. And in the MLflow, these are some random values that we got against this foo1, param, and so on and so forth. So all the details are logged here in the MLflow beautifully. So we created this experiment and we ran and we logged all the details here. So even if you kill your Jupyter notebook, and all these informations are alive and stored in a local database. So these experiments, you can always go back and refer to them at any point in time. So you could be doing multiple different iteration. I have another example. I will just show it across. So that can be very easily tracked beautifully as part of your execution. So now, in case currently the actual port that you are using is 5000, if you want to use a different port, you can actually change the port as part of this command in the set tracking URI and get tracking URI were used for changing the port numbers of the default 5000 and taking it forward. So I hope it helps you understand the hello world perspective on the tracking, how it is done, how we are actually doing it. Any question till now, I would be happy to answer, and then we will move on to little advanced one. Any questions, team? Okay, good. So the next experiment, let us take a simple regression as an example. Let me increase the font size. So here we're going to do a regression as an example. We're going to look at a data set and how we are going to predict using an sklearn elastic net as a model, and how we're going to process the data, how we're going to do an end-to-end management of your whole life cycle as part of the whole process. We will see that. So the data source for it is taken from an open source data auto mpg data set. This data set consists of 8 attributes, a small details. So this auto mpg data set I have already downloaded and loaded into auto mpg as a data set here in my data folder. So in the regression problem, the first thing is I'm importing mlflow, importing panda numpy, we know ml matplot library, we know. And sklearn consists of matrices. For identifying matrices, there are different matrices that you can do. Test train split is to split your data, and in the case of linear model is basically elastic net is what we are taking for processing this. OS is basically to interact with your operating system. So the data set, now that, as I said, under the data folder I have auto mpg data. I'm reading that in the panda as the data frame. Let me just first import the files, execute the import. Import is successful, and then I'm going to read the data. Once I read the data, I'm just displaying the head. These are the details that executed successfully. Now I'm defining set of columns for my data and do some refining the data frame. So I'm splitting this string and I'm dropping some columns, and I'm combining some, in the car name, I'm just replacing these details and combining them to the final car name column. So when I run this, the whole data is processed. Now now there are many columns are there which I am converting into a floating type, and separating dependents and the independent variable. X and Y are the one that I'm defining. mpg is the Y, and all the others are basically the X parameters. I'm running this. It has run successfully. Once I have the xy is split, dependent and independent variable, I need to create a test train split of the data. So I'm creating the test train split. Once that is done, and I'm defining a evaluation matrix, I'm going to take RMSE and mean absolute error as two evaluation metrics for my tracking. As such, I am defining this as an evaluation matrix. Okay, now let's look at a conventional method how we would be solving this problem, and in a ml flow perspective, how we will be solving the problem. So I'm first going to define and explain in a conventional method what is that we're going to do, how we're going to solve. Here, elastic net as a algorithm has two hyperparameters. I'm taking only two. There could be multiple one, but I'm taking for an example. I'm taking two hyperparameters. So I'm defining my algorithm with two hyperparameter with the initial value of, say, alpha value of 0.01 and L1 ratio as 0.15. So I'm passing on this value here, and as a linear regression model, and I'm doing a fit. And once the fit is done, and I'm doing a predict, and I'm obtaining the evaluation metrics, and I'm displaying the actual hyperparameters and the model performance for these hyperparameters. Typically, as a machine learning engineer, this is what you do. You provide different hyperparameters and see how your data actually gives a proper outcome in terms of your machine learning models metrics that you are trying to track. That is what we are doing. So we are interested on hyperparameters and the model performance for the hyperparameter that you are doing. I'm going to run this. When I run this, sorry, yeah, so for this value of hyperparameters, I got RMSE value of 3.26 and MAE as 2.44. Now, you initially defined your initial run and you are satisfied with this. So, as a next step, as a machine learning engineer, you could be using an approach of multiple hyperparameters and see how my model actually works. That is the next possible step. Now for that, I'm defining a multiple different value of your alpha. Alpha, these are different hyperparameters value you are taking. And L1 ratio, you are taking multiple values like this. So this is a conventional method. We have not come to MLflow yet. Okay. So here you could be looping in multiple ways in terms of using alpha. First time I'm taking 0.01, and you need to cover all the values of L1 ratio. And the next time you are taking alpha zero point zero 0.02, you need to cover all the values of this. So this is how you will do the actual iteration with two for loops. And you could be doing a display of this value like this. So when I run this, you will see something like this. See, I have an alpha of zero point 0.1 and L1 ratio of 0.15. I get an RMSE here like this. And I have an alpha of this and L1 ratio of this, I get an RMSE and MAU like this. It is literally very difficult. So you get so many runs that happen and you get multiple outcomes available here. It is very easy for a human to actually miss which is the best performance. Here, if you look at 3.26 as an RMSE value, here in this combination, I'm getting a 3.39 as an RMSE value. But equivalently, the MAU is also changing 2.44 to 2.55. So which is best? Here I have taken only two parameters. You could be having 10, 15. Then think of the complexity of tracking them, identifying which is best. The other problem that we face is in terms of uh, this is a very small sample, uh, like a small dolls data set that I've taken for your demo. In a real world scenario, you could be having a large data set with a lot of parameters you are processing. So you could be getting multiple outcome. It would be nightmare for a developer to actually go through them to see the details. Let's see how we are solving this using MLflow. Okay. So I'm going to call this with a new experiment. Okay. Regression with MLflow. I'm going to call this way. Okay. So I'm creating this experiment. So in this experiment, so now with MLflow start run, this is an experiment ID that I'm passing it on, and the same set of code that I'm going to take along with uh, a box plot that I wanted to plot. And when I'm plotting this, I wanted to save this image as well, part of my whole flow as such. Now, as part of log artifacts, I'm saying images. So now this is a simple experiment that I'm taking in terms of alpha and L1 ratio. Similarly, how we started, we're going to take 0.02, 0.15. and the same elastic net fit prediction RMSE value. Now here, instead of you printing it in the actual log, I'm going to do a log parameter. Now here the parameters are two parameters I'm passing, hyperparameter alpha and L1. Whatever the parameter I've taken, I will pass it on to here. And the metrics that I'm getting for RMSE and MAE, I will be logging on using log metrics. And not just this, we have as part of sklan something called log model. The whole model itself will get logged. So you start the process and you end the process with ML flow. So now if I run this, it's one run only. So think of this as a single run. I got the box plot details that I have received. The beauty of this is, see, I have created this experiment with an experiment name of a regression with ML flow. So now if I go to ML flow and I don't have that, if I refresh my screen, I get this regression with ML flow. Now in this, I have executed one run, and in this run, I have MAE and the RMSA value and alpha L1 score. All the details are logged here. So you could be asking, what is a big deal here? I will show the big deals shortly. Okay. Now, um, so now going down here, I have, I'm going to call it as probably with the same name so that you can understand the details. Copy this. So I'm going to put this R with say search. I'm going to call it, and similar to the previous case, I have taken all these values as hyperparameters and I've created two loops, and for all of them I'm going to get an image as an artifact. Along with that, I will be logging the parameters like log matrices and parameters. I'm going to run this. It has run successfully. Now going back here, it is called regression with ML flow search. And now if I go back here and it is not available, I'm going to refresh this. And now if you look at here, now you see the amount of information that has come in here. The amount of information in terms of how many logs are added as part of your, all these are different runs. And the beauty is all your matrices and the details parameters all are logged here. Now the reason why this is much better is all these experiments have logged. Now I wanted to do some a specific filtering. Now here it's only probably some 10 or 15 execution. I can actually use, say, matrices matrix dot, I'm going to call it as RMSE value greater than say 3.27. If I search for it, I will get only the specific items where I am looking for RMSE value which is greater than 3.27. Okay. Now again, you wanted to further filter based on say alpha value of zero point 0.1, assuming that 3.298 RMSE value with alpha value of zero point 0.1 is good enough for you, assuming you are taking. So this particular model I wanted to use to experiment on my production. I can simply select this particular run. So each and every run will have a specific set of run ID, and all the metrics details and everything were logged here, and I can reference the details here. Okay. So all the details are referenced here. Okay, so this is a way of filtering the details and going to that particular details. But now in some cases you would require, I want to take that model and process that model for my actual execution. How do I do that? That is the next example that we're going to see. So now we have done the first experiment in terms of how do you actually put that model available for you to use it. The next one is in terms of how do you, I will take another example in terms of, let's say, a classification as a problem. So here I'm going to do a classification of the details, and now a similar set of libraries. We all know what is this. Here decision tree classifier is what I'm going to take. I have car specific data. This data is coming from this car evaluation data set. I'm taking this data and I'm doing a basic data processing, and I am separating the data X and Y. I'm separating, and I'm creating test string split, and I'm creating a simple classification. Let me create this as live demo simple classification as an experiment name. So now I have created the experiment. Now here what I'm going to do is, we are starting this ML flow, and I'm setting some tags here, and I'm doing a one hot encoding of the data that I have received. So the one hot encoding of the data, I'm applying it for my test and the training data, and I'm saving this data to a CSV file. So this is in terms of a checkpoint. You are doing some data processing from your original data and saving the data to a CSV file. Now you wanted to track this particular file, what is happening in this file as such. There is a command called log artifact with a specific item what you wanted to do. So this step basically saves a copy of the CSV file in your ML flow, so that you can go back and access this particular file at any point in time. Think of the same log artifact. You can use it whenever you are doing a big amount of data processing on your data, so that a version of the data is saved as part of the ML flow as such. And you are creating this decision tree classifier, you are fitting this classifier, and you are doing a prediction, and your accuracy is the score, and you are logging the parameters, what is the max depths and max features that you are taking, and your accuracy is the matrix that you are logging it. As we discussed, there is an option called log model. So this log model helps you not just take the model, train the model, and log this model itself as a pickle file in your ML flow. So we have executed this particular code. The ML flow has completed successfully. And now if we look at the classes, these are the classes, it's all working fine. Now the name of the experiment is live demo. I go back to ML flow, I refresh my screen, I get a live demo. Now this is an experiment that I have done. The beauty of it is I click on it, I get the ML model that I have created that has come here for me. And not just this, there is an environment that the code, the CSV data that you have saved, the encoded one hot encoded data, a copy of the data is also available here. You can use this at any point in time. Not just that, your matrices and all the details are saved as well. Okay. Now, assuming you wanted to do a classification with multiple iteration, then you are saving that iteration details as part of your code. Then you can actually track them directly using your ML flow. What is the model? What are all the different related files and so on and so forth? And what is the data? All are saved part of this particular execution. You are doing another execution, it will save the details for that execution separately. and so on and so forth. So that is the actual purpose of this one. So there are a lot more that you can do as part of ML flow as such. So any questions? We have taken the base model, and we have tried implementing the details in terms of how you can actual flow is done. Here, one other detail that I wanted to mention is here there is something called log explainer, SHAP based log explainer. So this SHAP is an algorithm which is used for explainability of your actual execution. It typically takes around 10 minutes to 15 minutes for me to execute that. So that's why I've commented it, and you can try it there. So I will show some previous executions that were done, simple classification, where the last execution has this model explainability SHAP. This is how you will see the explainability details. They also provide option for you to use them as a numpy file as part of the understanding the explainability details. So this is also directly integrated part of your ML flow as such. So that, I hope, gives you an idea. I have so many other details also I wish to talk. For example, in terms of extracting the details, whatever that we are parameters that we are having here, we can actually directly use our Python library for interacting with it. All the information available here are provided as an API for us to actually consume as such. So here is searching run. Yeah, this is an example of that. Let me just quickly go through that. So I'm just importing that. I can choose a specific run that I wanted to extract. Now if I run, this will give all the runs that are done. These are some of the runs that you have seen. These are the runs that you are seeing here. Say it could be for the regression ML flow. So all the runs that you are seeing, all these are being provided here as a number. These are the run numbers that you are seeing, and effectively you can actually do the metric search directly here rather than doing that experiments there. It could be like I can say 3 and less than 2. Here I'm not getting. I'm sure that probably search 1. Yeah, some error that is happening. Does not exist. The data is not available there. So effectively, this gives you an example of how you can actually take that particular data as part of your ML itself and actually process that for experiment as such. And the other thing is, if I wanted to serve your model, you can use that something called ML flow model serve, where this can be used for your testing infrastructure. You wanted to test, you wanted to simulate the production environment, you can directly do that, directly serve using your detail as well. And you wanted to consume, you can directly consume directly from notebook itself. That is also possible as such. And not just that, once you create the ML flow models, you can take this model and deploy into anything in Azure machine learning or SageMaker or wherever that you want. It has connections. Basically, you can actually deploy them through code, or you can actually deploy them through a process that you can set for the ML flow as such. So this gives you an overview of how, from a developer point of view, many of the tracking part can be done automatically by using ML flow. That is being detailed on today's session. Okay, so there are many other pieces to it in terms of your automation part, automation in terms of the whole thing that I was talking about. You can automate the whole thing in terms of whenever from Git, whenever you are executing something on your notebook, you can think of putting your source code into a Git as a new version, and that Git commit can be taken up and a new build can be done, and that parameter can be directly logged into ML flow, and that completed build can be directly taken to a test environment for serving, and from there an experiment can be used. A test scripts can be run on the test environment to see whether everything is working okay. The whole ecosystem can be done integrating with MLflow itself. Okay, so I hope it gives you an overview of how you can actually implement the MLflow as part of your MLOps operations as such. So, any questions, team? Any questions? I
Uh,
hope
so, uh, one
go
small
on.
doubt, Prasanna. This is money.
Yeah, yeah,
Uh, yeah, in order to, if we are going to move this model to some of the Azure ecosystem or something else, we
yes.
need to just export the pickle file,
No,
and
you can.
we'll be using.
Yeah, it's up to you. You have an option with MLflow directly. There are commands which can actually
Okay.
directly take from the MLflow which model that you choose. That model can be directly taken to Azure machine learning as such. Just a single command that can help you take it as well, because MLflow already has a tight integration with Azure machine learning. Azure Machine Learning, SageMaker, Google, TensorFlow, everything is, the Google Cloud, everything is tightly integrated with MLflow as such. So you can, just a single command can actually help you take that model to live. No problem.
Okay. Okay. Fine, Prasanna. Thanks. Thank you.
So I hope it has been helpful to the team who have attended. And the source code and the presentation were already shared in the GitHub. And any other questions, I'm happy to answer. If not, I'm there is some chat. See, it was very okay. Okay, sure, sure. I will share the recording. I will share the recording to all of you guys. Not a problem. Yes, wonderful. If no questions, and thank you very much for all your patience, and looking forward for the next sessions. I will share the details on the next session. So next session I'm planning to do in terms of how, uh, from a data perspective, synthetic data can help, you know, um, do a lot of process at a very quicker way. So that could be the next item that I'm looking at. If you guys have any specific items that you guys want to cover, you can also share. It is, I'm most welcome, so that I can cover that topic as part of the session as such. Okay, all the very best, team, and thank you very much for patiently listening on today's session, and thank you very much for attending.